À tout de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, unité. Top, allumage moteur Vulcain. Allumage 2 EAP, décollage. Propulsion nominale. Tous les paramètres à bord sont normaux. Propulsion nominale.
Syracuse 4B and Heinrich Hertz satellite blazing a trail on board the last ever Ariane 5 across the equatorial skies, and we can hear the rumble of her engines as she flies over.
It's very impressive, and we are, 11 kilometers from the pad, and the delay of the vibration is a bit amazing. We cannot get tired of it, and we have a very good view of the launcher right now.
Nominal.
He's telling us that the trajectory is nominal, everything is going according to plan. 1 minute and 56 seconds into the launch. Fantastic view of Ariane 5.
Well, we have a very good view. I'm sure we will see the booster separation with the camera.
Nominal.
So the propulsion is working perfectly, nominally, as we say in the space jargon. And here we will see the booster separation. Yeah, we see it.
Séparation de 2 EAP.
Wow.
And we have confirmation from the range operations manager.
Look at this. That's absolutely amazing.
Those two boosters on the right and the left being jettisoned. The white dot in the middle, the Vulcan engine.
So they are providing 90% of the overall thrust. And so they have been jettisoned. They are 240 tons each. The launcher on the ground was 771 tons.
And we don't need them anymore, we're shedding weight.
So everybody is completely nominal. So next step is the separation of the fairing.
That's coming up in about 10 seconds. You can see on the top of the screen our trajectory on the left-hand side is the planned route for the vehicle. And separation there of the fairing is what it looks like.
Séparation de la coiffe.
We have confirmation there of separation of the fairing. So we don't need it anymore, Raphael.
Propulsion nominale.
Exactly. So we were 117 kilometers above the ground when we separated the fairing. So we crossed the limits of the atmosphere. We are now in space, where the remaining gas is so thin that the friction it generates on the satellite is very negligible. Just to mention also that we switch from real camera to 3D images now, because that's how we can follow the steps of the mission. The fairing was also used to protect the satellites from the noise generated at launch. We obviously need to jettison it correctly to follow the logic of shedding as much weight as fast as possible, because the lighter the craft, the faster it goes, in order to release H2SAT and Syracuse 4B in less than half an hour from now.
And that's the name of the game, of course, to lose mass so that we can climb higher into space. And the captain has switched off the seatbelt signs. If you look at our altitude at the top of the screen, 168 kilometers and climbing. So we have crossed what some people think of as the border with space, the Kármán line, which was at 100 kilometers above our planet. And yes, we can see Heinrich Hertz satellite for the first time. You said that they were going to see space the next time they saw the outside world. Well, now Heinrich Hertz can see space.
That's the case for the upper passengers. The lower passenger, Syracuse 4B, needs to wait a little longer in order to meet space for the first time. What we see is the black structure. This is the dual launch structure called SILDA. So it's used to accommodate the two satellites under a single fairing.
It's a very clever piece of kit because it allows you to attach one satellite at the front and then it protects the satellite in the lower berth. He's just told us that we have about 3 minutes roughly left on the main stage burn.
So thanks to the Vulcan engine, that's the engine of the main stage, we are gaining lots of speed right now. So in less than 2.5 minutes, we will go from 4 to 7 kilometers per second, which is very fast, obviously. And this is a huge structure. It's 30 meters high, filled with approximately 160 tons of cryogenic propellant stored in 2 different compartments, one for liquid oxygen, one for liquid hydrogen. You definitely don't want to touch it because it's extremely cold. It's 100 degrees below zero.
And it's incredible when you think that the 2 boosters on the side are burning at phenomenally hot temperatures. So you've got the very cold tank in the middle with the very hot boosters on the side when they are burning. And of course, that's just such a remarkable feat of human engineering, isn't it?
2 extremes side by side. So everything is going perfectly right now.
We're flying out across the equator. Our flight path takes us across the Atlantic, across Africa. We'll be heading out towards the Indian Ocean. And he's telling us that we have now picked up the signal at the ground station in Natal, which is on the northeastern coast of Brazil, and we're tracking the launcher using telemetry.
Yeah, so the launcher sends signals back to Earth all along the flight, which are recorded by a network of telemetry stations so that the teams can make sure that the mission is performing nominally. Again, that's a word that we will hear very often during this flight. It's like a relay race with one telemetry station passing the baton to the next one. By the way, the trajectory today is a little bit different than usual. We will release the telecommunication satellites on an orbit with an inclination of 3 degrees with respect to the equator, instead of 6 degrees as it's usually the case for this kind of missions. So it will be easier for the satellites to reach their final geostationary orbit. We were able to do so because we had some remaining performance on Ariane 5, and when we have some margin, we just give it to the customers. And so the first station to pick up the signal was Galliot here in Kourou. Now it's Natal. And then we will have other stations all along the flight path.
Coming up on the next sequence of events.
Séparation de l'étage principal cryotechnique. Allumage de l'étage supérieur cryo.
So he's just announced and confirmed a sequence of 3 very important and very delicate events there.
Yes, so the extension of the main stage engine, the successful separation of the main stage from the rest of the launcher, and just now the ignition of the upper stage. It's a super important step because, you know, there are 3 engines on the rocket. 4 engines, sorry. 3 are ignited on the ground, and this is the only one which is ignited in space at 200 and almost 40 kilometers of altitude. So it's a very delicate operation, and it's imperative that we succeed in order to continue the mission.